Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. I wish all of you a happy new year. I also wish that all pharmaceutical QA/QC teams grow stronger in new year with skill improvements. Today's topic is useful tips for HPLC and GC analyst. Let us discuss some of the important useful tips for running of successful chromatography techniques HPLC and GC. In this video, generic reference to various aspects of the instrument and analysis is done. Column is heart of the HPLC and GC. Utmost care should be taken to maintain them well. Performance of HPLC and GC largely depends on this important item. This is really the heart of the chromatography. There are several stationary phases and dimensions for columns. Typically for HPLC, you have 10 centimeters, 15 centimeters, 25 centimeters, etc. with internal diameter between 4 mm and 5 mm. Stationary phase absorbents are packed uniformly and tightly. Keep always the end caps firmly fitted. It's also important to see that the HPLC column is always maintained wet with solvent in it. Never allow the column to dry out. This can lead to cracks in the stationary phase and you will find inconsistent split peaks and drifted peaks. So after the analysis is done and after cleaning of the column, fill the column with 10% aqueous methanol and cap firmly the ends. The methanol protects the column from microbial growth. Flush the GC columns with carrier gas, mostly nitrogen, after completing the analysis. For GC columns, you have packed columns of 1/8 inch stainless steel columns, megabore 530 micron columns, 200 microns and 250 microns capillary columns with a length of 30 meters or more. There are also 1/4 inch copper columns packed earlier. Main difference between the packed column and capillary column is that the packed column will have the stationary phase coated on a support material and packed, whereas the capillary column will have a very thin film of stationary phase coated inside the capillary column. It is recommended to allow the carrier gas flow through the column for some time to ensure that any residues retained in the column will be flushed out after the analysis. This protects the column. Also note that when the column is removed from the oven chamber, make sure that the oven temperature is cooled to room temperature and unlock the detector side first. Then only unlock the injector side. This will avoid sudden jerks to the column that could disturb the stationary phase inside the column. Cleaning status of the column should be displayed on the column. This is important. After completing the analysis, wash the column with sufficient solvent as recommended and finally store in 10% methanol or store as recommended in the individual monograph. Never forget to put a tag on the column on the cleaning status. Alternatively, a logbook may be maintained with these details so that whoever takes the column for analysis knows its cleaning status. Store the columns carefully in the space provided. This is another important point. Store the HPLC columns in the designated racks with the end fittings firmly fixed. Keep the GC columns also in the designated box and store carefully to avoid any damages. Let us see the delivery systems. The salts of buffers will get deposited in the pumping system, causing scratches in the plungers. There is a buffer and another solvent in many mobile phases used for HPLC analysis. The salts of the buffer are likely to get deposited as scales in the plungers of the delivery system. So it is very important that the buffers may be washed out completely and ensure that it is free from any salt deposits. After analysis is complete, at least 30 minutes the column should be washed with aqueous solutions to achieve this. Check for any growth of microbes in the mobile phase reservoirs and clean when necessary. There is a possibility for bioburden growth inside the mobile phase reservoirs and can contaminate the pumps of delivery system. So it is necessary to clean the reservoirs free from bacterial growth after completing the analysis. The mobile phase should be prepared just adequate for the entire run. This will help to get consistent uniform mobile phase for the entire run. Keep a check on the pH of the mobile phase intermittently to ensure that there is no change in the pH or composition of the mobile phase. I noticed in several laboratories the mobile phase reservoirs in open conditions, leaving the lids hanging outside the mobile phase reservoir. This is not acceptable. The reservoirs should be in closed condition always. This avoids any accidental dust falling into the reservoir or loss of solvent from mobile phase. There should be suction filters fixed at the mobile phase delivery piping. The suction filters are necessary to filter off any micron level particles. The filters are available at 5 to 10 micron porosity filters. Once a week, the filters should be cleaned with hot aqueous detergent. You get good results with 5% aqueous nitric acid. Soak the filters with this hot solution for about 15 to 20 minutes. Repeat the process with fresh water at least twice. All pores will be cleared. All the buffer solution should be filtered through 0.45 micron nylon filter. Use always HPLC grade solvents. The buffers should be filtered through 47 mm diameter nylon filters. You get 0.45 micron porosity nylon filters for this purpose. You can get lesser porosity of 0.2 microns also, but generally 0.45 micron porosity is okay. When you use HPLC grade solvents like acetonitrile or methanol, there is no need to filter these solvents. Let us see the importance of the injectors. The length of the tubing from the outlet of the column and the detector is critical. In HPLC, never change the tubing leading to detector from column outlet. Extra column volumes will broaden the peaks. The length is critical. The sample should enter the detector as soon as it comes out of the column. Make sure that there are no leaks in the inlet or outlets. This can be achieved by gentle roll-on type ferrules. Never tighten too much. It may break inside the column, making the column unsuitable for further use. Gently fix with fingers. Even if it leaks, remove the connection and reconnect again. You will be successful. For leak-proof performance for GC analysis, the septum used for the injector port should be of good quality silicon rubber. Silicon rubber septa are airtight and leak-proof. You get silicon septa in the market. You may buy a silicon sheet and punch the exact sized septum also. It will be less expensive. The punch can be fabricated easily. The fixed loop 10 microliters or 20 microliters etc. for the rheodine injector should be handled carefully without any damages. The loops are fixed with an accurately calibrated volume loops help to inject the sample without any error. So it is important that the loop volume does not change. In the earlier models of HPLC, there used to be 510 model pumps and U6K injectors. External, separately measured volumes using airtight syringes were in practice. Too many bends in the pumping system from pump inlet to the detector inlet should be avoided. This is important. You should never touch the plumbing system to bend or relocate as you wish. Too many bends will impact the flow system. This is simple to understand. If there are too many bends and joints in the plumbing line that distributes water in household, the water flow will not be uniform. Let us see what kind of care is required to maintain the detectors well. Keep the detector clean for consistent results. Dirty detector cell can cause excessive baseline noise and decreased lamp energy in HPLC analysis. For cleaning the cell, reverse the flow cell inlet and outlet lines. Start the flow at a very low rate, ensuring that the back pressure remains below the maximum rating of the flow cell. Flush at a low flow for at least 1 hour. Flush with HPLC grade water until the effluent is neutral. If the cell is still dirty, you can remove carefully using a soft cloth. Clean with the soft cloth and replace. But if you don't have necessary tools, call the service engineer to clean the cell. The detailed manual supplied along with the instrument may be used to do this job. But unless you are sure of each step of disassembling and reassembling, never try this. FID of GC can also be cleaned easily by the thin wire supplied along with the instrument may be used. The flame ionization detector can be easily unscrewed from the base. The thin wire that can be used to clean out any residues in the detector. Then soak the detector in acetone for some time. Clean several times. Dry with dry air or nitrogen and reassemble in its place. For correct intensity of the flame in FID, a general thumb rule may be followed. Carrier gas, if it is X ml per minute, hydrogen should be X plus 10% X ml per minute. Zero air should be 10 times the X with a minimum of 300 ml per minute. This is a general rule for correct intensity of the flame for FID. For example, if the carrier gas flow is 30 ml per minute, the hydrogen should be 30 plus 3, that is 33 ml per minute, and zero air should be 30 into 10, that is 300 ml. But if the carrier flow is 10 ml per minute, hydrogen should be 10 plus 1, that is 11 ml per minute, but zero air is only 10 into 10, 100 ml per minute. In this case, the zero air should be 300 ml per minute. Let us see some of the important aspects in mobile phase preparation. Organic solvents and buffers are mixed in a specific ratio as recommended in the individual monograph. This point should be understood well. Retention times of the peaks will vary the way the solvent and buffers are mixed. For a specific analysis, for example, 90% buffer solution in 10% acetonitrile is the prescription. You mix in the ratio of 90 ml of buffer and 10 ml of solvent generally. But if you interpret as 90% buffer in 10% acetonitrile, The solvent should be diluted to 10 times with the buffer. In both the cases, the retention times of peaks may vary. To make it simple to understand, 1% solution means 1 gram is dissolved in sufficient solvent and made up to 100 ml exactly, whereas when 1 gram is weighed and 100 ml is added over it, it will have different concentration. The total volume will not be 100 ml and the concentration is not exactly 1%. Similarly, when you mix two solvents in a ratio as 3:2, the final volume will not be 5. It will be slightly less or more depending upon the solvents mixed. If there is a prescription to mix in the ratio of 60:40, you cannot take 60 ml in a measuring jar and make it up to 100 ml with another solvent. You have to mix 60 ml and 40 ml separately. Total volume need not be 100 as expected. So method of measuring and mixing should be practiced in the same way by all. So the SOP should have clear details. Filter the buffer solutions through 0.45 micron filter and degas. As explained earlier, to remove any particulate matter, it is necessary to filter. Degassing is necessary to ensure that there are no air bubbles in the buffer that could disturb the inlet pressure of the column inlet. The blockage of column inlet with particulate matter can easily be checked with excessive pressure recorded on the monitor. The measurements are done as volume by volume or weight by volume. In most cases, the mixing is done in volume by volume ratio, but where viscous liquids like amines are used, mixing is done by weight by volume. Store the mobile phase in borosilicate resistant glassware. Use always good quality borosilicate glassware for storage of mobile phases. Do not use soda lime containers. They are not resistant. Store tightly to avoid any accidental deterioration of the mobile phase mix. Water used in the preparation of buffers should be of purified water grade. You get variety of HPLC grade water. Check the UV cutoff also on the label for its suitability in your analysis. UV absorbent organic impurities should not be present in the water. You can also distill water in your lab, but it is really a slow process and may not be in a position to feed the HPLC requirement load. Let us see some of the other important points to note. The effluents collection bottle should never be in open condition and never be stored on floor. Use always a metal stand to avoid static charges. HPLC waste lines are open in many cases. The outlet is put into a bottle for collection of the waste. The HPLCs are installed in closed rooms in almost all cases. There can be poor ventilation. This can cause accumulation of vapors in the surrounding atmosphere. This can be health hazard. Also, any static charge that could generate sparks that can lead to dangerous situations. To avoid such things, it is recommended to see that the collection bottle is sealed properly without exposure or potential evaporation. Sometimes earthing the bottles by placing them on a metal stand is recommended. A secondary containment tray also should enclose the primary waste container. This is required to collect any accidental overflow from the primary waste container. An exhaust hood may be provided above the GC detector to expel out any toxic vapors that may come out of the FID detector. The hood should be placed appropriately so that it will not contaminate the detector by any extraneous contamination and does its job of expelling the vapors. I hope that these simple tips will help you to maintain your HPLC systems in good working condition and run the HPLC and GC instruments successfully. We will try to understand the other intricate features in coming up videos. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.